Alright, two things to note. The first is that a prism, you should know what that is, hopefully by this point in the video, but a prism is going to be any figure that has these two polygon bases. So we've got two triangle bases here, they're both polygons, and rectangular surfaces that connect those corresponding sides. We have three rectangular surfaces around this. We have the kind of left and right and the bottom of this shape. They're all built from the three sides of the triangles here. And then surface area, you should know that surface area, well, it's literally the area of the surface of the figure. If I were to take the area of all the different sides this thing has, all five sides that are on this figure, we would add all those areas up and we would have the surface area. You can think about it as the area that we would have to wrap if this was a gift, or maybe it was an object that you were painting, you would want to know how much paint to use. Any kind of thing like that could be a way to talk about surface area. And one way to do that is to go, okay, well, this has two triangular faces. So here we go, we have two triangles. And we've got three rectangular faces. So these are just quick sketches. My rectangles look more like general parallelograms here, just sloppy. That's okay. We're just going for sketches. Looks kind of like a weird eyebrowed face, but that's all right. What we want to point out here is that two of our rectangles have this length of 10 for one of their sides. So let's say that these two here have a length of 10. All of our rectangles have this width of 16. So we'll put a little 16 here on the top of all these. And then one rectangle on the bottom here has that width of 12, or length of 12, depending on how you want to call it. And then all of our triangles, or both of our triangles, have a height of 8 and a base of 12. So if you know your basic area formulas, you'll be able to go through this very quickly. Triangles use, let's see, I'll write this down here. Area of a triangle would be 1/2 little base times little height. So the triangles both have 1/2 of 8, which is going to be 4 times 12, which would give me 48 square units. They didn't give us units of measure here. We have two rectangles that have 160 for their area. And then here we have 12 times 16. If you're not familiar with this particular one, you can go in and do a little bit of multiplication very quickly. We know that 6 times 12 is 72. And we know that 10 times 12 is 120. So we get 192 for the area of this rectangle. That's kind of like the bottom of this shape right now, if you want to think about it that way. Well, if I want to find the surface area, all I do is add these up. Now there's two that have 48 for their area, and there's two that have 160 for their area, and there's one that has 192. And so instead of trying to do that on my head, which I could do given enough time, I'd rather just save time and go ahead and do this here. Just type it in very carefully, double check your numbers. 2 times 48 looks good, 2 times 160 looks good, and then 192 at the end. And we get a surface area of 608. So there we go. That's one way you could go about doing these problems. Now, in the long run, if you do a lot of these problems, patterns will pop up, things will keep kind of happening as you go. The main thing here is going to be, first of all, there's two things I should say. This part is going to be very familiar, very similar as you move through these problems. All prisms are going to have those same corresponding bases. You have, in this case, two triangular bases. You could have a rectangular prism, which has two rectangles for the top and bottom, or the front and back, whatever you want to call it. You could have a cube would be very different because it's a very special case. You could have a pentagonal prism, which has a pentagon for the front and the back. So you'd have two of those. But every time you're going to have two copies of your base. So if we define big B, as we did with volume a while back, if we define big B as the area of your base, you could say, well, the surface area of the prism is going to have two copies of the area of your base. Well, let's take a look for just a moment. Notice that all three of these rectangles, all the rectangles in fact, share the 16? Well, when we came up with this portion here, I'm going to come down here and do a little scrap work. We had 160 plus 160 plus 192. We'll wait for the camera to catch up here. So 160, 160, and 192. This was all of our rectangular stuff. But really, this was 16 times 10 plus 16 times 10 plus 16 times 12. All three terms have a 16 in common, so I could factor out our 16 here, and we would be left with 10 plus 10 plus 12. So this is factoring out a common factor. This is sort of the opposite of the distributive property, if that helps clear that up. And what I would notice here is that 10 plus 10 plus 12, if I go back to my original figure, 10 plus 10 plus 12 is actually the perimeter of my base. What I actually did right here is multiply the perimeter, so this right here is the perimeter of my base. I multiplied it by the height of the prism. So the perimeter of the base was multiplied by the height of the prism. This will always happen with a prism. So up here, the last part of your surface area of a prism is going to be P times H, where P is the perimeter of the base. And there you go. This is actually going to be the surface area formula that I would use for any given prism along the way.